Okay, today we're talking about slope, which is very, very similar to rate of change. You're going to notice that. Slope is the rate of change. It can be positive, slanting upward, or negative, slanting downward. So slope is the rise over the run. I kind of touched on that in the last video. The rise is the vertical change between any 2 points, and the run is the horizontal change between the same 2 points. So take a second, pause the video, make sure to copy this down, as well as what the change is. Okay, make sure that you have positive would be that upward motion and negative would be that slanting downward. Okay, so if we wanted to find the slope of this treadmill, we want to look at the rise 10 over the run 48. So what we can do is we can write 10 over 48 and simplify it. Right here is our slope of the treadmill, 5 over 24, because we divided both 10 and 48 by 2. Okay, so let's look at a couple more examples. The graph shows the cost of muffins at a bake sale. Find the slope of the line. Okay, so a line is made up of unlimited points. I want you to know that even if they don't have dots, this is a point, this is a point, this is a point, this is a point. I could make unlimited points. I could zoom in and make more points, and then zoom in again and make more points. Infinitely many points. So even though there's a point here and here, could I make a point here? Sure. Could I make a point here? Sure. We always like to pick points that pass through integers. It just makes our life easier. So if I use the 2 points that they gave us though, 2, 4, and 3, 6, I can find the rise over the run by finding the change in the 2 points. I'm going up 2, so I'm rising 2, and it's positive, and I'm going to the right 1, so it's positive 1. So the rise over the run is 2 over 1 or 2. Normally, when we do slope, we either leave it as an improper fraction, leave it as a regular fraction, or change it to a whole number. Slash integer, because not all integers are whole numbers, right? So the main thing to remember is we don't make it mixed. Just don't make it mixed. All right? So if we wanted to translate what it looks like, if we see that it's going up, it's positive. If it's going down, it's negative. If it goes to the right, it's positive. If it goes to the left, it's negative. Why is that? Because if we looked at a full quadrant, or a full, all 4 quadrants, this is positive, this would be negative, and down would be negative, okay? So it kind of helps you see that to the right is positive and up is positive, while to the left is negative and down is negative. All right, so the table shows the number of pages that Garrett has left to read after a certain number of minutes. The points lie on a line, so find the slope. So these 2 points lie on the same line, so do these points. We can choose any of them. We just need to find the change in the y over the change in the x. Remember, always the change in your dependent variable over the change in your independent variable. So pick any 2 points. Go ahead and pause the video and try it, and then watch what I did, okay? So here we go. If I find the difference between 12 and 9, 9 minus 12 would be a negative 3, and 3 minus 1 would be 2. So it would be a negative 3/2. Okay, to check, choose any 2 different points. Okay, I picked maybe the 3, 6, and the 7, 5. So we're using these 2 points or these points versus these points. So 3 minus 6 is a negative 3, and 7 minus 5 is a positive 2. So the difference is a negative 3/2. So it works. In linear relationships, no matter which 2 points you choose, the slope or the rate of change of the line is always a constant. Okay, so it doesn't matter which ones you pick. You could have even picked 3, 7, and 12, 1. Okay, you'll just have to simplify a little bit more. All right, so now you try it. Find the slope of this line and find the slope of this table. Okay, I'll be back in just a second to show you the answers. So make sure you pause it. All right, let's talk about the answers. For the graph, we would rise 1, 2, 3, and we would run 1, 2, 3, 4. So 3 over 4. And notice that they're both positive. If I went the other way, okay, and I went down 1, 2, 3, so negative 3, and I went to the left 1, 2, 3, 4, so negative 4. Notice if I simplified that, a negative divided by a negative is a positive. So no matter which way you go on the graph, you should still get a positive 3/4. Okay, if we pick 2 points over here, let's just say we pick these first 2. Okay, let's find the change from our y's, 1 to 2, would be a difference of 1, and the change from 2 to 6 would be a difference of 4. Okay, if we did it from here to here, positive 4, here to here, we're going 1. So 1 over 4, or 1/4. What if I picked, I don't know, these 2 points? Okay, the change from 1 to 0, negative 1. The change from 6 to 2 would be negative 4. So this would be a positive 1/4. Over here, these would have both been negative as well. I don't know what I was thinking. So that would be a positive 1/4. If we went this way, that would be a +4, and this way would be a +1. So you could do this going from the right to the left. You're still finding the change in them, and no matter what, it's going to be positive if both the changes are negative. All right, so the slope formula, I need you to write this down. So go ahead and pause the video and just write that down and then listen to my explanation. Okay, so hopefully you paused it and had a second to write that. What we do here is the slope m of a line passing through 2 points is the ratio of the difference of the y coordinates with the difference of the x coordinates. We kind of talked about that when we saw it, but what if we were just given 2 points? Okay, that would change things for us a little bit. So instead, this formula is what we use to find slope, okay? We got to make sure that, one, the points aren't equal. So you can't use the same point or else that won't work, okay? Because then you're going to end up with 0 over 0, which we know is not good. That's undefined. So it doesn't matter what point you define as x1 and y1 or x2 and y2. However, the coordinates must be used in the same order. Okay, so that means if I used this point first and then this point, I have to make sure that this negative 4 is in the same position as the 3. For example, if I plugged in 3 as my second point, okay, so that's my y2, then this would have to be my first point, or my y1, which means this has to be my x2, which means it has to fall directly under it. So basically, we just write the points like this and extend the line and make sure that the other points are above and below each other. Okay, so when we do this, we're subtracting because in the formula it tells us to find the difference. Difference means to subtract. So 3 minus 2 is 1, and negative 4 minus 1 is a negative 5, which can be simplified to a negative 1/5. Okay, let's look at it if I reversed it. Okay, if I put 2 here, I have to put the 1 here. And if I put 2 there, then I got to put 3 behind it and find the difference with the negative 4. So the difference, 2 minus 3, is a negative 1. And this is a not, so it's an addition, and 1 plus 4 is 5. So really, I have a negative 1/5. So you can check your work by reversing the points. All right, so go ahead and try these to practice. These are all the different ways to find your slope. Go ahead and try them. Pause the video. I'll be back in just a second with the answers. Okay, so if we wanted to find the slope of this one, it would be the change in the 3 over the 15, and 3 over 15 would be 1/5. Now this slope is going to be decreasing. Do you see that? So if we look at this kind of a slope, this actually would be the negative 1/5 if it were a line. But really, if we're looking at just the slope itself, we can say it's 1/5 or a negative 1/5. But really, we know that because it's decreasing, it's the negative. Increasing or decreasing? Right away, we know it's a positive. So it's going up 1, 2, 3, 4, and over 1, 2, 3. So 4 over 3, or 4/3. We can leave it improper. Remember, don't change it to a mixed number. All right, for this one, we're finding the change. So from here to here, it's +2. From here to here, it's +1. So we've got 2 over 1, or just 2. Could we use these 2 points? Sure. +1, +2, we can find it. Or what if I was looking at the points in reverse and I said, okay, I'm going this way, -1 and -2. Then a -2 over a -1 is still a +2. All right, so find the slope that passes through each pair. This is where they want you to go back and use this formula, the y2 minus the y1 over the x2 minus the x1. Okay, so I'm going to take my y's and find their difference. Make sure the 4 stays in the same position as the 5 and find their difference. Okay, these are not knots, so they're plus. If I take the opposite of a 2, or it's not a -2, it's a +2, right? So 4 plus 2 is 6, and 5 plus 3 is 8, so 3/4. Oop, gotta click it. There we go. Over here, I'm finding the difference. Okay, since I did this point as my second point, I'm gonna do this one as my second point this time. So 5 minus -3 over our -6 minus 3. So we get 8 over -9, or a -8/9. It doesn't look like that's supposed to be a negative, but it is. It just looks like it's extended because it's kind of shrunk. Okay? All right, so the equation, the slope equation, is y equals mx plus b. So if I see an equation, I can pinpoint the slope as my m. And it's basically the coefficient. The coefficient is the m. And so this would be my slope. Okay, so if I wanted to find the slope in this one, I would have to first go through and rearrange the problem. I need it to be in this y equals mx plus b form. So what I'm doing here is I'm going to manipulate the equation. I'm going to add 6 to both sides, and I'm left with -4x plus y equals -x plus 2. I want y by itself, remember? So I need to get rid of the -4x by adding 4x to both sides. And now it's in that y equals mx plus b form. This is called slope-intercept form. So what would be my m? If you look, it's 3. Okay? So that's how you find slope from an equation. So just to recap, today we have found slope from an equation. We have used the formula to find 2 points. We've looked at it just if it were in a picture, as well as if it were in a table or if it were in a graph. All right, I'll see you next time. Hey, wait, just kidding. Try these 2 problems. I'm totally lying to you. I wasn't done. Okay, go ahead and try these. Pause the video, and then I'll be back to show you the answers. Okay, for this one, if you wanted to manipulate it, you would say, okay, I'm going to add 1/2 to both sides, which means I'd be left with 1/4 x plus y equaling 3.5. If I move the 1/4 x to get it in y equals mx plus b form, if I delete this, we'd be left with 1/2 x, but it's a negative, right? Plus 3.5. So my answer of slope would be a -1 and a -1/4. Okay, over here, I'd have to first get rid of this division of 2 by multiplying by 2 on both sides. So I'd be left with 3y equaling 6x. If I take 3 away from both sides, I'm left with 6x equaling a -3. So my slope is +6. And that's all I've got for you today now for real. See you next time.